All right. Hello and welcome. It is the 21st of May. This is the Deep Dive Thursday here at Code Mentoring. We're going to look into Git, introduction to Git. So I've got 10 commands that we're looking through today. Starting off, we're going to probably start off with a sample project. So I might share my screen as well. So I'm going to start off with a sample project inside GitHub and run through some of the basics that we use all the time at Code Mentoring. So we'll have like a git init / clone, git status, git add, commit, log, branch, checkout, merge, and a bit of a rebase. And then we might look into
Tristan?
how. Yep.
Yeah, your screen has become like an infinite.
I know. It's cool looking, isn't it?
Looks cool though. Yeah.
So it's all part of the effect.
Nice.
Nice. So I'm gonna come into GitHub to the Code Mentoring project, and I'm actually gonna create a new repository, and we might just call this, say, Git intro. Like this. This is. I'll probably delete this afterwards. Maybe I'll leave it here, depending. Oh, just had someone join. All right. So first thing I'm going to start off with, right, is so what is Git? You know, we've seen these GitHub repositories, right? We often go to something like this, but what is Git in its essence or its concept? Does anybody know why we use Git?
Control the version system.
Control the version system. Yeah. What does that mean, though? What does that exactly mean?
So it tracks of the file history.
Yeah. Now, why is that important? All right. So let's say we've got a person over here. All right, person 1. And they're working on some stuff. Right? And we've got a person 2 over here. Now let's say these guys actually want to work together on the same project. Right? So let's say we've got a bunch of files that these guys want to share between them. Now we can do things like Dropbox and whatnot, and that works pretty well for, you know, sharing various documents like Google Drive and whatnot. But why is this not a good system for coding?
Because if you want to reproduce a bug at a particular point in time, you need to know what version of code or what copy of code they were using.
Right.
So to understand that and what code you used when you released a product, then you want to know the exact version. And so instead of keeping exact versions manually, use a source code control system, and it will tell you exactly what version you used when you label it or branch it.
Right. So you're talking about a sense of time.
Yes.
So being able to essentially have different points in time that represent different versions of what we're working on. So if we were to, say, take all of these files, right, and we organize them into, you know, a section of work, right, something that we did. Right, let's say this is just give it a bit of a border, right? So let's say this is something that person 1 did, right? They modified 4 files. Now, you're saying that you want to actually have that on here as like a point in time, right?
Right.
So a point in time in which those 4 files or whatever, right, were changed or edited or deleted. Maybe one of them was deleted, right? So we'll use red for that. Maybe we added a new file, right? We'll do a green for that. And maybe we had 2 other files that we changed. So we might use like a yellow. This, right? So how do we how do we represent this? Right? Let's say person 2 comes along. Right? They've also done some work. It's pretty common, right? If you're working with a team of developers. Right, now they've also done some work. Now let's say it's different. Let's just say they just added one file. Right, so it's a smaller piece of work. Now, how do we consolidate these two things together? Right? So this is really where Git becomes our friend. So Git is a way of managing what we call source control, or source version control. Right? So the idea is you have this timeline, and on this timeline there are different events that happen. Right? Now these events are things like editing a file, creating a file, deleting a file, maybe they're kind of the primary actions that you would do to a project. Right? So let's say this person has added a file. So you might almost visualize this as they come along here, right? And there's a new version in time. Now, this is really cool because what I can do, right? Person 1, let's say that they created this. Let's say that they wanted to get the second person's work. But what they can do is they can actually pull this down like this. Right? Now this process of, so they've pushed first, right? This first line here that they did, person 1 created this first. These little circles. Right, these are called commits. Right, forgive my M key. He's a bit greedy. He likes to duplicate himself. So these little blue circles are commits. Right? So let's say this first person pushes their commit. Right? First one here. Let's say this is the first commit. Then person 2 sends another commit. But now, right, on the first person's computer, right, they don't have this new file yet, do they? And that's what this here is for, is after that this person does something, right, they can do what's called a pull. They can pull down this person's work, right, and have a look at it. So now, right, both of these things get joined together. So this piece of work gets added with this piece of work. Right? Sounds pretty good, doesn't it? Any questions on anything we've covered so far on the concept in Git? So I'm curious, when we merge this together, right, does this always work out well? Is this process of adding this commit onto this, does that always work out? Is it always perfect?
No, there can be like merge conflict or something.
A merge conflict. What is this merge conflict? So let's use another example. Right? We've got person A, person B on each side. Let's say person A, right, adds a new file like this. And that person commits this file. Right? Like this onto the Git branch. And then we have person B who also does the same work. Right? So they actually do the same thing. Now let's say this person pushes this. All right, so this is now a push that's been done. So it's been pushed up. Now what does pushing mean? What does the concept of push do?
You upload your.
I've committed this onto the branch.
You upload your file to your branch.
Not to the branch exactly. There's a thing called a remote. So with Git, right, Git can have a destination. So you can have multiple places. So for example, GitHub is a remote. right? You can also, there's also GitLab, or there's also Heroku, or Netlify, or these other things. They are destinations that replicate the source tree, right? This tree of branches. And we'll get into branches a little bit later on. But this is remote. Let's say in this case, this black line, right, when it gets pushed up, this actually gets pushed up to GitHub. So let's just call this GitHub, right? And we'll say this is the master branch. So we'll get into branches a little bit later. So person A has pushed this file. Let's call this file file 1. They call it 1. Now, let's say person B also creates a file called 1. Now, when they try to push this onto this, right, this is not going to work. Right, this is gonna say, hey, you can't do this because person A has already created this file. So what it's trying to do is merge this file here and this file here together. And that is what's called a merge conflict. So we'll look into how to resolve that stuff potentially today as well. So that's kind of why we use Git and how it works. Let's jump into, before we jump into this though, do you guys have any questions on anything we've covered so far about why we use Git, how commits work, how remotes work? Right, remote's probably a good example, right? So I might draw a little bit more around that. So let's say you have your computer, right? And on this computer, right, you have your entire tree of Git. Right, I'm just going to use a line and an oval for this, right? So this represents an entire Git tree. This could have multiple things on it. But for now, let's just say it's this, right? Your computer contains this. Now, you've got another person over here. This is just another way of drawing out. Let's say person A. Right. Person B. Right. Now, let's say we have this remote, right? This remote might be called GitHub. So it actually contains the whole thing. Move them up here. So say this is GitHub. All right, but then so this is what's called a remote, right? That both people push to. So both people are pushing to this, and GitHub is responsible for kind of maintaining how everything. It's what we call a source of truth, right? Everything on GitHub is considered to be the truth. But then you might have another environment that you deploy to, right? That actually has, let's say it's a subsection of the commit history, right? So it doesn't have all of it. Maybe it's just a particular branch or something like that. So we'll use like a different color for this, right? Use like a purple, right? Let's say this is Heroku. So when you're pushing, you actually have the option. Normally, it will push to the origin. This is what's called an origin, right? And you often do this when you set up a existing repository. You'll say git remote add, right? Who's seen this before? Origin, right? HTTPS github.com/ maybe code mentoring, so on and so forth. Right. So what you're effectively doing here is you're establishing this relationship, this black line here. Right. That's called a remote. You can also establish another line. Right. So let's say person B wants to add this. They can do that. So they can you can actually do this multiple times. So you can have git remote add, and then we might call this Heroku. Right? Heroku, and then I might have some URL related to Heroku. So now person A, or sorry, person B, whenever they push, right, by default, it's going to go to origin, which is, they've set it to GitHub. But you can also go git push Heroku master, and you'll push the Heroku branch, Heroku origin, like this, not remote. So that's actually how remotes work. You can actually push to multiple locations. You can have as many of these as you want, right? So any questions on how remotes work inside Git? Notice I'm not saying GitHub, right? There's a difference between Git and GitHub. Git is the underlying technology, right? GitHub is the service that takes in multiple people's commits and branches and whatnot and amalgamates them and provides that user interface. But Git is a separate thing from GitHub, if that makes sense.
So I just have one question.
Yep.
So such as the person A creates the one GitHub and the person B join. So
Yep.
when the person B push to the GitHub, they always ask us to pull before we
yeah, that's a great point. That's a great point. Thank you for saying that. So in this case here, right? So person A does the first commit. So commit 1. Right? Now person B, or person 2 in this case, right? They try to do the second commit, but before they do that, right, they have to pull down these changes first. Right? So this has to happen first. So before they can commit to this, or rather before they can push this up, they have to merge it together. So yes, that is a very good point. So that's why we're always doing things like git pull to make sure that we have the most recent changes. Right? So all of this at the moment is just working with one branch. So we'll get into branches a little bit later today, but for now, I just wanted to sort of make sure that these concepts are clear for you guys. Just title this remotes. Any questions on anything we've covered so far? Great. Okay, so what does this actually look like from a coding perspective? Okay, so before we were created this little Git intro. All right, I might actually turn off this stylish. There we go, just so you guys can see what I see. Okay, so this is what a Git repo looks like, an empty one inside GitHub. So I'm going to copy this line here. And what I'm going to do is I'm going to establish locally, I'm going to establish a repository, and then I'm going to establish this link here to GitHub and say down here, right, git remote add. That's what this is doing. This is establishing this relationship between these two. Right? So let's go ahead and do that. I'm going to open up a new folder. VS Code is going to... What is going on? Okay. Cool. So deep dive, we'll go git intro. All right, so just open up this folder. You guys can see the screen okay? I'll zoom in a bit. Okay, so let's go ahead and create. So who knows how to set this up as or track this as a GitHub project? All right, it's a new folder. All right. So what do? We have two options.
Git init.
Git init. That's correct. So what that's going to do is to our file system, it's going to say, hey, this folder that we're living in now, this is now a Git project. So treat it as so. In fact, you'll actually see if we do ls-l h for hidden, maybe it's A. Yeah. So you'll see here, it's actually created a .git folder. All right, so ls.git. So you see here, we've actually got some, it sets up some of these things for us. Now we don't necessarily work inside this folder. This is what Git uses internally. But if we go open here, we should, if you enable it inside Finder, if you're on Mac or on Windows, you can enable hidden folders. Right? This folder exists. It has all the information on everything that we're doing. Right? So that's the first command done. Right? Now another way of doing this is what if we already have files inside here? What do we do instead? Instead of a git init.
If
clone.
You have it, yeah.
Yep, we do a git clone. So let's say put in, where were we? In this case here. So let's say person A does the git init, right? It does some stuff and pushes it on GitHub. Right? Person B would do a clone. Instead of doing it init, because the stuff it already exists. So they'll clone this down instead. Right? So this might be an init. Sorry, Figma's dying on me. All right, so this is an init, this first one, and then person B will do a clone because it already exists. Great. Okay, so let's go ahead and add our first file. I'm just going to make it a text file. All right, call it hello.txt. Well, actually, let's set it to a README so we can see it in GitHub. Markdown file, right? Let's call this intro to Git. I'm gonna save this, right? So you'll notice a couple of things that have happened inside VS Code. Now, VS Code is very useful with its integration of Git. So you can see here, right? It's shown this green, right? Now, green means it's a new file. You currently haven't added this into GitHub yet, or to Git. We also see here, right, we've got this change, right? This number, this notation saying, hey, look, there's one file that you haven't added into Git yet. So I suppose this is another question, right? And that brings us to our second talk, which is what is adding and how does adding work? So can anybody tell me the difference between adding and committing?
Adding will just like let it track it.
So in this case, right, let's use another example. So we put our Git branch. All right, we put our change that we did. So adding is kind of or committing is kind of like a two-step process, right? Or rather 3 steps. So let's say the first step is to make some changes. The second step is to add them. Right, and the third step is to push them. Oh, sorry, commit them. And then actually the fourth step, now that I think about it, is to push them. All right, so what does this look like? All right, so the first step is pretty self-explanatory. Right, one is you make some changes. Right, so you've just got these individual files that you've made some changes to. Right, again, yellow representing a change file, green new file, and red deleted file. Right, so that's our first part. Now the second thing that we do is we add them. Right. Now, also called staging. Right, you might see this sometimes called staged changes. So what this means is it says to Git, I am ready. I'm ready to prepare these things. So in this case, let's just say these two files. Right? So just these two, right? We've modified this file and we've added this file. Now, what will happen in the third step? Right? This is step 3. So in step 3, right, we commit them. Now, what do we need when we commit something, team?
Message.
A message, right? So what we're doing here, right, is we're creating a new commit on the branch of time. Remember, if we go back to our first example, right, it's creating a new version of time in our timeline. Okay? So we need to have a message that we tag. Right? So we say did something. That's what we call our message. Right, now if we're doing this inside Git, this will be, who knows how to do that? Who knows how to tag a message inside Git in the CLI?
-m.
-m. So it will be git commit -m. This. So git commit add m. All right. So now, right now our code has been changed. I'm just going to move that line down to me. Okay. So we made some changes. Right. We've added these two files, not all four. Right. So we still have some 2 files here that are left untracked. So I should probably point that out. Right, untracked files or changes. Right, sometimes you'll see error messages saying cannot commit with untracked changes. Please commit your changes before continuing. So that's what that means. Right, is that these files have been added. Right, they're ready. Right, they're prepared to be committed. But these guys, they're still sitting there. And actually, after we've committed, right, and we go back to the first stage, these will still be there. And often what you'll do is the reason why we want to have this third stage, this adding part, is because, this part here, is because you might have done a bunch of work and you want to split it up into different commits. So let's say we had this one here, right, and then these changes actually went onto a separate one, a separate commit. That's the reason why we have this adding part. Now inside Git VS Code, it's very easy. Let's create a second file, right, to illustrate what I'm talking about. Second.txt something. Okay, so if I go back here, look, see how it has a 2. So currently, right, we're in step 1. Make some changes. So it's this here. We've got 2 files that we've changed. Right. Now the second step is to add one of them in. In fact, I might split this up to like this, make it easier. Right. So now we're in the second stage. So I'm going to go ahead and inside VS Code, I can actually add everything. Right. So stage all changes, it will say. So that will actually, everything that we've done, right, it will draw this black box around them, ready for the commit. But in this case, right, let's just do 1. Right. So now I have one of them like this, right? So one of them is staged. In fact, I'm going to swap that around with the README first. So the README has been staged, right? But the second.txt, that's not staged yet. Okay. So now, when I commit, it's only going to commit what we've selected to be committed. Make sense? So let's go ahead and say added readme, like that. Boom. Okay. So let's say I didn't want to do that. I'm actually going to introduce a new command for you guys. That's off the plan. So I actually wanted to show you guys how to do this inside the command line. So does anybody know how to undo what I just did?
Git abort.
Nope. Abort implies that we're in the middle of something. So in this case, right, I added this blue circle, but I actually want to go back.
Rebase.
Right? Reset. Right? So we've got a couple of options here. So git reset. Now, when I'm resetting, I have the option of doing a hard reset or a soft reset. Does anybody know the difference between the two?
Hard reset takes off the untracked files, discards them.
Mm-hmm. Can I get them back again?
No.
No, I cannot. It completely deletes them. So we've got this concept called a head. You can see this inside Git. Now, this refers, essentially, imagine it like a cursor. Right? As the cursor moves around inside a piece of text, right? So you can jump to the start of a line, you can jump to the end of a line, you can go up a line, go down to the end of the paragraph, right? So you can select various things and then delete them. So that's kind of how, imagine each of these circles as a letter inside a paragraph, right? Now the head is where you're currently at. So in this case, right, we want to actually go back. So we want to reset the head to go to the previous version. So we have two options. One of them is a hard reset, and one of them is a soft reset. Now, a hard reset, it grabs all this commit that we just did, and it completely wipes it. There's no way to recover it. Whereas a soft reset, it resets. So let's say we're going back. Let's say we're going back 2. Right. The way you do this is use the head tilde by pressing Shift tilde, and then 2. Right. What that will do is it will go back 1, 2. If you just want to take back the last one, right, you can just do head like that. Tilde 1. So you can actually use this as long as you want. There's also other ways to do this with like accessing this specific commit ID. But that's more advanced stuff that we won't get into right now. Right, in this case, we just want to go back 1. So I'm actually going to go soft because I don't want to delete it. And I'm going to go back head tilde 1. Now, I think the reason why we can't do this right now is because that was the first commit. So I don't think we're able to go back 1 commit, unfortunately. So in this case, I might actually just go rm-rf.git, right, and completely remove that. Just going to reload VS Code. Usually you wouldn't do this, but this is just because it was the first commit. There might be a way to do it, but I'm actually not aware of one currently. Okay, so just to repeat what I actually wanted to do, right? We want to go git add, and we want to instead of using the cheating way of using VS Code, it's good to know how to do this manually through Git, right? So in this case, we want to add the path. So in this case, it's going to be readme.md. Git init first, right? So git add readme. So VS Code should actually automatically reflect those changes. So we've just done that manually. Git add readme. So it's the same thing as clicking on here and clicking this add button, stage changes. That's how you do this with the CLI. Now you might ask, why do you need to do this in the CLI? Why can't I just use VS Code? Right? Not every environment. Say you're doing this on a continuous integration server, or say you're doing this on production or something like that, and you just want to fix something really quickly. You're not going to be able to load this inside VS Code. You have to know these commands manually. So that's how we use the git add, right, to stage that. Now the next one is the most common one we'll see is git commit. In our case, we're going to do -m. There's lots and lots of commands. I recommend you guys check them out. But sorry, lots of different options for this. But in this case, we're just going to do -m. We'll say added readme, like that. Now, what that will do is it will remove it from the stage. Right. So that's now been updated, and we now have our first commit. Any questions on anything I've covered around adding and committing and resetting?
Someone is asking, like, what is a CLI and CLA in the chat?
A CLI stands for command line interface. Right. So anything you type into here, right, is a CLI. So if I just open up a normal terminal, right, without VS Code, right, this is what we call a terminal. Now, as developers, you need to get comfortable and used to this, right? I think mine's a little bit broken. So I might open up a different one. I use iTerm just because it's different styling. So anything that you use inside here, right? This is a CLI. So for example, npm, right? Who's heard of npm before? That's a CLI, right? Command line. We're using it inside the command line, and it's an interface. Interface in the same way of, who's heard of an API before, right? Application programmer interface. Right? Interface is just something that you're using to talk to someone. Your phone could be considered an interface, right? It's an interaction between things. So a command line interface is something that allows you to talk to the computer through the command line. That's what a CLI stands for. So good question. Any other questions on anything we've covered so far? Great. So let's move ahead. I'm going to, what's the one we have next? Let's load up our list of, so we've gone through init. We haven't done status yet. So status is something that VS Code shows you inside this window. So if we do git status, you can see here, it just gives us a list of where we're at. So in this case, it's saying that it's untracked. So second is untracked. Let's say we make a change to README, right? Something else. Now, if I save this file and I do the same thing again, it will show me that I have some changes. It says modified README. Right? If I undo those changes, I do it again, it's removed that. So what it's doing is it's comparing to the previous commit. It's saying, has this file changed? In this case, it has. So why don't we try and add the change that we just did? Try git status again. There you go. So now it's in green, saying it's been added in. Right? What if we add both of them in? Right? On branch master, changes to be committed, right? Means they're staged. Modified the README and added the new file second.txt. If I do git commit, right, both of these things will be added on that commit. Make sense? Any questions on anything we've covered so far? How are you guys finding the explanation? Anything you guys are stuck on, or?
I have a small question. It's not what you've talked before. It's about the when you write in CLI, you have some dark gray text. Is it an extension?
Yes, that is an extension. Yeah.
What's the extension?
I forget exactly. Look into something called ZSH.
ZSH. Okay.
Yeah, very, very common. Yeah.
Thank you.
No worries. Cool. What else? So we've done Git init. Yep.
Sorry. When I do
Question?
the commit, I got a problem. They told me I need to set up. It told me to git config global. I tried, but I face problem with that. Before I do the commit.
Did you do Git init?
Yes, I did. And
what's the error? What's the error saying?
It told me that please tell me who you are.
You might need to log in. Yeah, run through. I forget the exact command for that, but I think you might have to set your user. Set user. Let's just have a look here. If you're running, if this is your very first time running Git on your computer, you might have to run this command here.
Oh,
so that just tells Git who you are. So have a look through some of the documentation on that. Yeah. So that allows you to set your name. It also allows you to set your email as well. So you can set git config user.email and then put your email in there. Cool. What else? So we've done init, right? We've done status. We've done adding it in. We've committed. We haven't done log yet. So what does git log do? Well, if we do here, git log, it actually tells us the history. So git log is the command line way of saying, give me access to this tree, like this. So that's what git log does. It goes back in history and shows you all the commit messages for all of the commits that you previously have done on that branch. So you can get quite fancy with this. You can actually filter for things. I think I posted the other week a really cool snippet that I found. Yeah, this one here. Git log all grep. You can actually search for a particular commit message, which is really useful, especially if you've got hundreds and hundreds, if not thousands, of commit, especially in a large project across all these different branches. So you can actually search for a commit message on any branch, which is pretty cool. So git log can have some pretty powerful effects. For example, there's a lot of graphical user interface tools that allow you to work with Git. All right, Git Kraken, for example, is one of them. I'll show you guys what it looks like. I might give you a little bit more of a visual idea of how these branches fit together. So this is for the Code Mentoring Learn project. Right? As you can see, it's quite complicated. So we've got all these different people working on all these different branches, and you can see the Git. So this is what Git log allows you to do, is see the log of everything. Right? So as you can see, quite a complex project. A lot of things going on. So Git log, I recommend reading the documentation for it. There's a lot of really powerful things you can do with it. Cool. So any questions on anything we've covered so far? On branching, or sorry, on logging or adding or status, or I think we're going to get into the meat of it now, which is how branches. So what is a branch? Can anybody tell me?
Is it like an instance of your own code, sort of?
Kind of.
Yeah, I don't know how to describe it.
Kind of.
Yeah.
So remember how we referred to this as a timeline? Right. A Git branch is an alternate version of time, which sounds quite fancy. So let's say in this case here, we'll call this branch master. Right. So a branch allows somebody to come off way out over here and do their own stuff. They don't have to worry about affecting the master branch. So they can come over here and work on all the commits and the changes and whatever else that they need to do, right? On their own computer. And they can add as many of these things as they want. Make all these little statements and debugs and fixing things and whatever else. And that's not going to have any effect on the master branch, right? Other people can add some stuff here. Now, what's the problem, right, between this one here and this one here? These two guys. What's the issue?
Like one is ahead of the other? Or?
Yeah, so this one's 3 ahead of this one. And this one is 1, 2, 3, 4, 5, actually, 5 ahead of this one. So what Git does is allows us to merge them together. This is where, and there's a couple of strategies for this. And this is where Git becomes very powerful. It's also where a lot of people get a little bit confused and they're not quite sure how to do some of these things. Okay, so who knows the 2 main ways to fix this problem?
One way is to merge the master branch into your own branch.
Mm-hmm. Let's call this the feature branch. All right, so what this is using a system called Git Flow. In fact, this would be called develop. And I'll talk about Git Flow a little bit later. I know I'm a little bit over time, but I apologize. And we'll call this the feature. So you have feature, and then usually have a slash, and then you just call this my changes. All right. So you're saying you can merge master into this. All right, that's one way. What else can we do?
Rebase.
Somebody mentioned this earlier. Say again?
Rebase.
A rebase?
Yeah. No.
Yep. Yep. So you can rebase. So what is a rebase? So I think before we jump into that, let's look at what a merge looks like. Right? So what does a merge do? Well, a merge is between 2 things, between commit A and commit B. Now this can happen anywhere, or between any branches. So let's just color this as a slightly different one. So we're trying to merge this together. I'm just going to ask if someone's got their microphone on, just to make sure they mute themselves, because there's a bit of rustling around. So a merge is when, let's say this developer on the feature my change, right? Let's say there was something happened here in this commit. Now in this commit, there was a special change, right, that this person needs for this branch. So this is a really, really common case for doing a merge. Now, when you merge, right, it actually creates a new commit. So this is technically more accurate. Right? You want to merge this with this, and whenever you do that, it actually creates a new commit. So that's what this here is. So let me just change these colors to make it a little bit more obvious. Let's say it's yellow. All right. So we want to grab this commit from develop. We want to merge it into, well, not just this commit, but all these changes. Right. Remember, with this green one being the thing that we want. We want to grab this. So merge, right, grabs these guys, merges it into this, and creates a new commit. Right, new commit from the merge of develop. All right. So this is a really common technique. All right. And we can do this quite simply. Who knows the command to this? If we wanted to merge develop into feature my changes.
Git merge develop.
How do we do this?
Yep,
git merge develop. But what do we have to ensure first?
That you're in the correct branch.
That's correct. So how do we do that?
Git branch.
No.
Git checkout.
Git checkout. Git branch creates a new one. So down here, right, when we see how we did this. So this here is Git branch. Feature, what do we call it? My changes. Right? So that's what this does. Is it creates a new branch. Right? You also have to check it out here. So git checkout feature my changes. Right? So now we've created this new branch, and now we've jumped onto it. Now the head belongs here. This is where the cursor currently is. If you don't do the second one, right? If you don't do this, you're still here. But by having that second one, you jump over to this one. Make sense? So to merge, we don't use branch. What do we do? A git checkout. Right, feature my changes, and then we do git. So now we're here. Head is on this one, and then we want to merge this in. So git merge develop. Now sometimes what will happen is let's say this file here, right, conflicts with this file here. All right, so we got conflicting files. So when you're doing a merge, right, these two files, you'll have to consolidate them somehow. So what does this look like? Okay, let's actually I'll show you guys what it looks like to create this branch. All right. So let's go git branch dash branch feature my changes. Right. Just created that branch, and we can go git checkout feature my changes. Okay, so what I've just done is I've come from here, right? I've created the new branch, and now my head lives here. All right. So let's go ahead and create a change. So let's change the title, right? Introduction to Git webinar. All right, so save that here. Now let's also edit that. And we'll commit this. So say changed title. We'll delete this stuff. Now we'll save it. What the hell? All right. So change title. Now let's go back to, so we're currently on feature my changes. Let's go back to master, git checkout master. And you'll notice if I open up that README, see how the change is gone? Because it doesn't live on this branch. So if we go back, all right. See how it differs between the two. That's because this one here has changed it, and we're about to change it here as well. So we're deliberately trying to create a merge conflict. Intro to Git workshop. Right? Now let's commit this and say updated title. Okay. So let's go git checkout feature my changes. So now we've come back to this. Now we want to merge this in. All right, this is going to deliberately create a merge conflict because both of these branches have changed the same file in the same location. So let's try it. Git merge. In this case, it's not developers. So we're going to use master. So git merge master. Uh-oh. Automatic merging. All right, conflict. Merge conflict in README. Right, automatic merge failed. Fix conflicts and then commit the result. So it hasn't created this purple circle yet. Right, this doesn't exist. We're somewhere in between these two. Because it's saying, I don't know. Git is saying, I don't know how to resolve the conflict between these two red circles. You have to do it manually. Right? So any questions on how we got to this before we resolve it? Is anybody lost?
I have a question.
Mm-hmm.
Each dot is a version, right? There. In
a
the
commit.
branch. Okay, a commit. That's a version. When I'm gonna do the merge, I merge the version of one branch to the version of the other branch, or I just merge all the versions that I have in one branch and bringing all the versions to the.
So you're grabbing all of these changes. I see how this is the root. All right, this is where both of them stem from. Right? So when you merge, you grab everything, right, based from the off the root, and everything off here, and you try and put the two together, mesh them together. That's what a merge does. And we'll get into rebasing in a second. Right? Rebasing does something different. But we're doing a merge at the moment. Does that answer your question?
Yeah, I have that. Thank you.
Great. So
I have just one question.
Yeah.
So when we find that conflict, who gonna solve that? Is mean A and B need to discuss each other to decide which is the final version, or who gonna?
Great question. Yeah, great question. Often it requires discussion. Yes. Now you might have found that you have to be careful when resolving merge conflicts, right? Because this stuff here, this could come from a really crazy other merge conflict thing or some other PR or something like that, right? There could be a lot of different changes in here. So when you're resolving, you have to be very careful to make sure that you don't remove somebody else's work. Okay? So yes, often if you're unsure, I would often just ask the maintainer and say, hey, I made changes to this as well. Right? What's more important? Now sometimes it's actually a combination of both. Sometimes Git was not intelligent enough to work it out, but you actually want to have both changes. Sometimes, right, you both change the same thing and you want to make sure which one is correct. Right? So let's pretend, and this is the difference between what we call incoming, right, and current. So the current change is what we see here. Where are we? Intro to Git. Right. So this is what we changed in this yellow circle. Right. This is what we currently have. Now this is the incoming one. Right. It's incoming. So the develop, or in our case master, is the incoming change, and that's what we see reflected here. Right. So the first one is the current change. The second one is the incoming change. You'll actually see in VS Code it's highlighted. It actually creates these markers for us. Right? Deliberately adds these things in. Git does to say, hey, you need to fix this before you keep going. Right? Now, in VS Code, we have this really nice option of selecting. right? Accept current change, accept incoming change, so accept the one from coming in from master, accept both changes, right? Compare changes, so we can actually see the difference split, right? This is the current one, this is the incoming one. So you can actually see the difference between the two, which can be quite useful sometimes. And then the other option we've got is start live share session. So that answers your question of, do I need to talk to somebody about this? Sometimes you do.
Is that like, so let's say you would, like, you want to use some changes from one of the branches and some changes from the other. How would you do it then?
Yeah, so in that case, you have to go through each conflict manually. So in this case, we only have one conflict, right? There actually could be multiple. So you have to work out which one is appropriate depending on the given context. There's no one answer to this.
Gotcha. And if I do that in VS Code, would I do that in that file there, or how would I do that in VS Code?
I would use this in VS Code, to be honest. I find it's a really nice tool. So you can actually accept things like this. If you right-click on this, you can actually see here it says accept all current or accept all incoming. So there's a shortcut there, right? In this case, let's see what it looks like if we accept both changes. Now we don't want this, do we? That's not correct. So in which case, which do we feel is more appropriate? Right, intro to Git workshop or intro to Git webinar with this something else? I'm gonna go with the second one. So that means this one that's coming in here, right? Somebody else has done work. We're actually going to accept that other person's work. Okay. So also just a fun note, if you do Git status in this, it will tell you, right, you have unmerged paths. So it's basically saying you're in the middle of a merge. Right. Also, if I run git log, I'm still only seeing the two changes. I'm going to go ahead and accept the incoming. All right, so we've let this yellow circle take precedence, and then it's asked us to commit. So once you've finished all of it, you've added all the changes, right? You add this in. So after you fixed it, merge changes, you press the plus icon. If you want to press the plus icon on all of them, you can do that too. Stage all changes, right? And then you just commit. So we're just going to our terminal, and this will finish our merge conflict.
Sorry, Tristan. So let's say like you accept both changes. Like let's say you wanted some from one and some from the other, then you would accept both and edit the file and then save and commit. Yeah.
Well, you can actually do it case by case. So with each conflict, you can go accept incoming, accept current, accept both. You go through manually each one.
Gotcha. Okay. Thank you.
Yeah. No worries. So to finish off this here, we're going to go git commit. That's going to finish off that merge. All right. It's going to ask us to make sure it looks good, and then we're going to press X, and there we go. All right. Now, if we do git log, we'll see we have the original commit. Right, we have our change title. Right, so this yellow one. Then we have the other change title. Right, this yellow circle. And then we also have the new purple circle, and the purple circle is the merge that we see here. So that is how merging works.
So I have one question related to merge. So in this merge command, it will change both the master and feature matrices, or it's only bring the code from the master to the matrix?
That's a great question. So I'm glad you asked that. No, it only changes what you've merged into. So currently, right, this one doesn't have these changes yet. So what will typically happen is you'll do this, right? And then this person here might do a little bit more work, right? And then what they'll do is they'll actually merge this in to develop, like this. Now it has it. Make sense?
Yes, it's okay.
So at this point, right, once we merge in here, right, develop does not have all these changes. It does not have them yet. It's only when we merge the feature into develop that it becomes available for everyone. Okay, so this is how feature branches work. That's the reason why we run this methodology, is so that people can work in their own sandboxed environment, and they only merge into develop right once it's ready. So this is, you can have multiple feature branches running at once. Each feature branch can correspond to one person or one team if you wanted to. It can be merging all the time, right? So that, yep.
Yeah. So the master will be the in the place that every developer in that team look into, right?
Yeah, it's the source of truth. Yeah, that's correct. So I know we're running a little bit over time, but do you guys want to go through rebasing? And do you guys want me to show you the difference between what we've just done here and rebasing? Yes, or do you guys want to? Yep.
Sure.
Cool.
No, yes.
All right. So rebasing solves the same problem in a similar way, but differently. So I'm actually going to go ahead and copy this stuff. All right. I'm going to remove this because we all understand that now. All right. So this is rebasing. So this is merging. This part here. All right. This is rebasing. So very different. So same idea. Right, is we have the yeah, we'll leave that for now. We have these two yellow circles. Right, we want to get these 3 commits. Right, and we want this. I'm gonna delete all of these, make it a bit easier. Right. We want to get these 3 commits inside here. Now a merge, right? We see what a merge does is it grabs it and it slots it in and actually creates a new commit. Now who can tell me what a rebase does? Anybody know?
For what I read, I haven't done it yet, but it's to put together the branch. Like to add your versions to the.
Yes, but how is that different from a merge?
I think that.
So I'll tell you what it does. I'll tell you what it does, and I want to use colors. I'm glad we use colors for this, right? So a rebase actually, it's a good way of thinking about it. Is it replays the commits, right? So what does this mean? So let's say we started with the yellow circle, right? These are the 3 changes that we want. So we have the red circle, right? We have the green circle, and we have the yellow circle, right? So currently, the branch that we're on doesn't have these commits, doesn't have these changes. So what we can do is we can merge, as we've already seen before, right? Or we can do something called a rebase. Now what a rebase does is instead of grabbing this stuff and trying to mush it together, it replays the commits. So it grabs all these guys, right? And it replays them one by one, right? So it goes through and it replays each one. It does this one first, right? Then it does this one second. And each time you do this, right, you have to resolve the merge conflicts. So in this case, it's fine. In this case, it's fine. But in this case, it says, hey, you've got a merge conflict here, right? You changed it here in the red one, and you changed it here. do you want to do about this? Now, there's a couple of things you can do. You can actually abort, right? So somebody mentioned aborting before. Now, what abort will do is it will scrap this entire thing. It will say, don't worry about anything we've just done. Just take me back to here. Take me back to this yellow circle. This purple one doesn't exist because there's no merge. Right? Take me back here. Right, that's what aborting will do. Git, and we do this with a git rebase abort, like this. All right. So that's one way to do it. Another way to do it, let's say you successfully resolve it, is you can just keep continuing on until eventually you get to this part here, right? And then once you've got here, then essentially what you have in the second stage is these guys are now cleanly, right, added together like this. So in actuality, I'm going to duplicate this. Right, this is the rebased. Let's say this is the original version. Right. So this is the original version, and this is the rebased version. Right, rebased feature. So what we've effectively done, right? Going to move all this stuff over, give ourselves a little bit more room. So what we've effectively done is we've added these 3 commits at the beginning of our feature branch. Right? So let's go remove these like this. Right? Grab these guys, the original one. I'm going to move that up. I'm going to put these underneath. Now each of these link together. Right? So that is what a rebase does. Make sense? So now these guys link together.
When I have to choose this rebase instead of the...
That's a good question. I personally feel that a rebase is cleaner a lot of the time, because it basically has a cleaner Git history, so that eventually, right, when I merge in, right, I don't have these purple things, right? So it's a cleaner history. However, right, this process of going through each manual commit, now your PR could potentially have 100 commits to it. Right? Do you want to manually go through every single one and resolve every single merge conflict? Not necessarily. And that's kind of where a merge comes in, because it allows you to do it all in one go. Right? It says, grab everything, smush them together. So I'll typically do like a rebase. If I have like a lot of commits that are quite dirty and like logging and remove, fix, removed, console log, all that sort of stuff. What I'll often do is I'll actually grab all of these commits and I'll rebase them into one commit, and I'll add that at the end. That's a pretty common technique that you see a lot of people doing. So that's kind of the difference and distinction between how a merge works and how a rebase.
Can you repeat that last one, like the part of what you do? I didn't understand very well.
So what I'd often do, like you might have like in here, right? You might have 100 different commits. That's common, right? You'll often see some pretty large things. So what I'll often do before I merge in here is I'll grab all of the commits that I did and I'll rebase them into one commit. So it's a clean history. And then I'll just merge one commit onto develop, if that makes sense.
So that means you rebase yourself?
Yes. Yes, I do. So we've covered a lot today, team. Any questions on anything we've covered so far? I'm just going to check what we had left. I think that was pretty much it. Yeah, Git merge and rebase. That was it. So I'm gonna hand it over to you guys for questions on anything that we've covered so far today.
Tristan, I have a question.
Yeah.
So when we do team project, everybody has a branch.
Mm-hmm.
Is that right?
That's correct.
Okay.
So what you'll often do is you'll come into this is a really common thing you'll see. All right, you'll come into code mentoring. Right. Now, typically, right, you don't work on a PR unless it has an issue assigned to it. All right, so come into our issues. All right, we'll find one that someone's working on. For example, Rajat, you're working on this right now, right?
Yeah.
He hasn't written a proper ticket. We'll find another ticket. Let's say this one here. Oh, Kim didn't write a proper ticket. Come on, guys. That's a good one. Yeah, this is a good one. Okay, so you'll get a story. So we're all about stories here at Code Mentoring. As a social person that wants to find my friends on Code Mentoring, I want to search via a name or email for people I know. All right, so it's giving you context. All right, what we should do. Clearly outlines what we're going to do. It gives us some details of this. So in this case, I think it's Lee was working on this, right? He will create a new feature. You might call it feature / search users. And that becomes his branch, or whoever else is working on this becomes their branch. So they go ahead and they work on stuff, and they work on stuff, and they work on stuff. Now, this here, right, this is not automatic. This is technically what we call a pull request. And a pull request means somebody comes along and checks everything that you've done. Checks all these things. Right now, you don't necessarily check each commit one by one. It's usually you check the files, everything that's been changed. Right now, if that pull request is successful, then they'll accept it and it will get merged in. Then this whole branch gets deleted because it's already in here now. Right? So that's how you work as a team. The idea is you spin up these branches, and then as soon as they're ready, you merge them in and you delete the branch. You don't need it anymore.
Now I get it.
So,
thank you.
Yeah, of course. I'm glad it was useful. Git can get quite complex, so I don't blame you guys for getting confused. And we're just scratching the surface of the things that it's possible, possible to do inside Git. There's so many cool things you can do. But this is kind of how, I'm going to show you guys a picture. I highly recommend. Where did I have that? This one here. Right. This is what we call Git Flow. Now we haven't spoken about the difference between master and develop yet, right? But we kind of just focused on the orange and blue sections that you guys see here. Right, branching off a feature. This feature has not been merged in yet. This bottom one, right? But this top feature has been. You can see how it branched off, did some commits, and then it merged in. So this is actually the process. This is the branch. What we call a branch strategy. This is what we follow mostly in code mentoring. I'm not going to get into hot fixes or release branches or things like that, but the most important thing for you guys to understand is the difference between a develop and a feature branch, which is exactly what we do. So, yeah. What other questions do we have, team? Anything I've covered on so far?
So you say that when you finish, you will delete one branch. So can we check the history of that branch, or it will permanently disappear?
Yeah, you can. You can. That's a good question. So if we come into GitHub, where are we? So let's go to a pull request that was closed. Closed PR. Let's say feature friendship, right? So if we scroll down to the bottom, it will say, I deleted the feature friendship branch, restore branch. So Git actually allows you to restore it, right? But it does actually delete it. But you can restore it inside Git.
Oh, that's cool.
It's very cool. It's very, very cool. Good question. What other questions, team?
One question. What's a fork?
A fork. So a fork, essentially, is grabbing this whole tree and copying it. And now you have access to everything here.
Right. Cool.
That's what a fork is. And often what you'll see is you'll see somebody fork it, right? They'll work on some stuff. So they'll come along and they'll add all the commits that they want to do, right? And then often you'll see someone do a pull request, right? Over here, like this, right? From another person's repository. That's really common. Now, when we first set up Project CM, this was the strategy that we were using, but it's annoying and complicated, and you guys have to keep working on your own branch, and then you also have to keep pulling, right, from the main branch, right, from the main repository. So I decided to remove this idea, right, and everyone's just been added to teams, so you can only work on certain branches, which is a cleaner solution. What else, team? Cool. Well, I'm going to go ahead and stop the recording. And if you're on YouTube, thanks for coming. Join us next week on Thursday.